So at the beginning of the section, I said that we were going to talk about ionic compounds and covalent compounds. And now we've spent the last 4 videos talking about ionic compounds. Molecular compounds or covalent compounds are much easier to name. So they're sometimes called covalent. They contain 2 or more nonmetals. And you will recall from looking at your periodic table, the nonmetals are this yellow part and hydrogen. Okay, so those are the nonmetals. These are atoms that are going to share electrons. With the ionic compounds, the electrons were transferred. And so here we're not going to have charges. And the prefixes below are used to name molecular compounds only. If there's only one of an atom, it's mono. Usually we don't use mono unless it's the first atom in the name. You'll see some examples, we'll talk about it. Di means there are 2, tri 3, tetra 4, penta 5. These should be relatively familiar if you look back to your geometry classes. Hexagram, hexagram has 6, and so 6. Okay, so let's see how we use these. We would call this compound with PBr3 phosphorus tribromide. Okay, the next one has 2 chlorines, so it's a dichlorine monoxide. So notice that I'm adding the IDE to the one that's behind. The first compound just gets its name. If there are 2 of them, I put a di in front of it. And here I use the monoxide because there's only 1 oxygen. There was also only 1 phosphorus, but it's in the front, so I didn't say monophosphorus tribromide. Okay? Again, this last one is going to be carbon tetrabromide. And there are 4 of them, so we'll use the prefix tetra. Notice I'm not trying to balance anything because I don't have any charges. I just write down what's there. So we want to write the formulas for the following compounds. Here we have a carbon, just 1 carbon, and a tetrachloride. That's 4 chlorines. Carbon monoxide is carbon with just 1 oxygen. And phosphorus tetrachloride is phosphorus. And there are 3 chlorines. So these are really a much easier naming system. You just have to be careful because you can only use it if both of the elements are nonmetals. If you have a metal, you have to go to the ionic system where you have to worry about all those charges. So let's do some mixed practice. Okay, so first we've got this one. First, the thing you want to look at is, do you have a metal? If you have a metal, it's ionic. So aluminum is a metal, and so we have an ionic compound. We're going to have to use the ionic naming system. This first is an aluminum. We need to look to see whether aluminum is whether it's a transition metal, whether it has 1 or more forms. It does not. It's always got a +3 charge, so we don't have to worry about that. This SO4 is a polyatomic ion. And if we look it up, it's sulfate. A sulfur with 4 oxygens is a sulfate. Okay, so let's look at the next one. We've got CaCO3. This is a common antacid. Ca is calcium. We need to ask ourselves, is that a metal or a nonmetal? It's a metal, and so this will be an ionic compound. This CO3 is carbonate. This is why you need to memorize your polyatomic ions, because otherwise you just look like alphabet soup. N2O is our third one here. A nitrogen and an oxygen. Both of these are nonmetals. So we can use the prefix system, or the one that we use for molecular compounds. And we'll just say what's there. Di, because there are 2 nitrogens, so it'll be dinitrogen oxide. And lastly, we have a laxative. Mg is magnesium. And magnesium is a metal. So we've got an ionic system here. We've got hydroxy. So we're going to call this hydroxide. We're going to put the IDE on the end. And so we've got magnesium hydroxide. Okay, next up, Lewis structures.